All right, today we're diving into something called Profunctor optics. Now, I know, that's a bit of a mouthful, but stick with me here because it's a name for a really simple, but honestly, a mind-blowing idea. The concept is this: there's a secret shape to information, a hidden pattern that connects pretty much everything, from the code running on your computer to the natural world all around us. So let's go find it.
So let's kick things off with a kinda wild thought. What if I told you that the logic that makes a computer program run follows the exact same rules as, say, a living thing trying to keep itself in balance? I mean, it sounds a little like science fiction, right? But what we're about to uncover is that this hidden connection, it's absolutely real.
Yeah, and this isn't just some random coincidence, not at all. It's pointing to something much, much bigger. A profound secret that modern science is really just starting to get its head around. We're talking about a kind of universal blueprint for how all complex systems tick.
All right, Section 1, a profound secret. So what is this universal blueprint we're talking about? What are we actually searching for?
Okay, so here's the core idea. There's this single abstract shape, a universal structure, really, that governs how information flows, and not just in computer code, but in all sorts of dynamic processes. Now, when I say shape, I don't mean something you can physically see or touch. We're talking about a pattern of connections, a deep underlying structure.
But here's the catch, right? You can't just look at a computer program or a living cell and see this pattern. It's an abstract structure, a web of relationships that is totally invisible to the naked eye.
So, that's the big question, isn't it? If this universal structure is invisible, how on earth are we supposed to see it? Well, it turns out we need a special kind of lens.
Which brings us to Section 2, the lens for data. And that special tool, that lens we need, you guessed it, it's called Profunctor optics.
So what is Profunctor optics, really? I mean, the formal definition is that it's a mathematical framework for visualizing and analyzing data flow in complex systems. Okay, but a much better way to think about it is like putting on a pair of special goggles. Goggles that let you see the hidden pathways that information itself travels along.
Yeah, you could just call it a lens for understanding compositional systems. And that word, lens, is so important here. It's all about bringing something that was fuzzy and hidden into sharp, crystal clear focus.
And this amazing tool comes from a really fascinating field of pure math called category theory. The best way to think about category theory is that it's the study of pure structure, like literally the study of blueprints. It doesn't care if a building is made of wood or steel or bricks. It only cares about the structure and how all the different pieces connect to each other. And that focus on connection, that's the whole secret.
Okay, on to Section 3, building with simple parts. Because the real power of this lens, where it gets all its juice, comes from one single fundamental idea: understanding how really complex things are built from really simple parts.
This is a principle called compositionality, and the idea is actually super intuitive. It just says that you can understand any complex system if you can break it down into its simplest little components and then figure out the rules for how they all snap together. It's just like Legos, right? If you understand the individual bricks and how they connect, you can build literally anything.
And the process is just as simple as it is powerful. It's a three-step recipe for understanding, well, anything. First, you identify the simple parts, the little building blocks. Second, you figure out what each of those parts does on its own. And third, you analyze the rules for how they combine. That's it. That's the engine that makes this whole thing work.
Which brings us to Section 4, the shape of everything. Okay, so we've got our special lens, and we have our building block principle of compositionality. Now, let's actually put on those goggles and see that hidden pattern out in the real world.
Because when we use this lens, when we look at the world this way, something truly incredible happens. That hidden, abstract shape we've been hunting for, it starts popping up everywhere. Okay, now this is where it gets really fascinating. Check this out. Through the lens of Profunctor optics, we can see that the way information flows through a simple computer program shares the exact same deep structure as the learning process in a neural network. You know, that process called backpropagation? But get this, that very same structure also shows up in how a cybernetic, self-regulating system keeps itself in balance. We're talking about one single, abstract shape that connects computer code, artificial intelligence, and even systems that behave like living things.
All right, Section 5, a universe of connections. And I have to stress, this isn't just some cool, abstract party trick for mathematicians. No, way. This way of thinking opens up a whole universe of connections, building bridges between fields of science that honestly seemed totally separate before.
What this framework is doing is acting like a powerful bridge, almost like a Rosetta Stone, for some of today's most advanced fields of research. It's creating a common language, so specialists in totally different areas can talk to each other and share insights about these fundamental patterns of structure and flow.
And believe me, this is not just theory. We're seeing it in practice all over the place. In AI, it's completely reframing how we think about machine learning, with these concepts like backpropunctor. It's being used to study self-regulating systems, which, by the way, are sometimes playfully called cybernetic kittens. It's also leading to these powerful new tools called Bayesian lenses that help formalize the entire field of cybernetics. This stuff is the absolute cutting edge of applied category theory.
So if you take away one thing, let it be this. Profunctor optics isn't just a neat idea. It's a new language, a formal, precise language that gives us the power to finally see and to talk about the invisible connections that secretly structure our code, our technology, and maybe even our entire world.
And that leaves us with a pretty big question to chew on, doesn't it? If the very same patterns are shaping our computer code and our world, you have to wonder, what other profound secrets are still out there, just waiting for us to invent the right lens to finally see them?